Welcome back. A little further along in the project. Just going to tip this up here a little bit. You can see the PCF chip is still down in there. I'm not sure if I can get some more light right on that. There we go. What I've done, you've seen the RGB LED, I took that off. I kept one of the channels just for this one little LED over here. And I'm going to get my little plastic pointer. Using the power supply for the back of that LED to power up the VCC on the infrared sensor, the motion sensor. I've supplied it with a ground wire, and I've taken its signal pin or its data out and put it into pin 1 of the I/O expander. So I have pin 0 driving this LED over here. Then I have pin 1 reading data back from the infrared motion detector. It used to connect to pin 3 on the sketch. I deleted pin 3 and inserted the read routine for the expander there. Now I'm going to put a link to this library. This is actually even a different library. I found it to be a little more stable with reading the input. I still haven't experimented with trying to see if I can overclock the I/O expander chip to 400. Some of the data sheets have said that they do run at 400, which is pretty cool if they do. Most of them only say 100 megahertz. As you can see, the light went off, so it's not seeing my fingers moving. It must be below the height to trigger it, so I'll just move my thumb over top. It comes on. I'm still using the same short timing sketch, so the timing cycle of the LED and whatnot here is a little bit faster than the original motion detector sketch. Of course, I'm moving my hand near it. Just also going to take a quick second to mention, you see some of the stronger shadow down here. That's actually from the lamp that I've installed at the back of my bench, which is the white light from a flatbed scanner that I harvested from one of my other CNC projects. Well, those lights are actually pretty nice to actually work with. They're also a very good true white, and it's actually been pretty handy to inspect a few things lately. But I do have a bit of shadowing, so I'm going to have to get a little bit better light source here. So I'm hoping this stuff is showing up. But anyhow, this is probably going to be the last steps of figuring out how that PCF8574 chip works. Ooh, yeah, that's that weak wire. I just made it reboot. This contacts inside this wire going into the jack. I don't know if they're corroded or just worn down, because that old Motorola plug is ancient, but it has, I think I mentioned in the other video, I think when I checked it, it's actually 2.5 amp 5 volt supply, so that's pretty good for right now. What I'm going to do next, now that I've got it working the way I need to on Arduino, I need to figure out how I'm going to do the level shifting and get it to run from one of the ESP8266 modules. And for those that haven't seen them, that's one there. That's one of the ones from oops, I bumped the camera. That's one of the ones I got from Hari. I have an older one that I'd gotten myself, which is pretty much identical, except it comes with it came with the header already installed, which is a bit of a bummer because I like the way that Hari does it. This is the way some of the stock ones have the header pre-installed when you get them. If you get them, don't put them on this way. Try and do it the way that Hari shows in his video, where it's way more breadboard compatible to do it that way. But anyhow, next will be to see if I can move this exact project with some sort of level converter, so that it can run on the 5 volt side of the board, and then the 3.3 volt side can power the ESP, So I'll probably use one of my small DC to DC buck converters. Got a few things that I can try. I might have a look and see how many amps that all draws. It might be fine to do, say, 5 volts from the buck converter, and then just put one of my 3.3 volt linear regulators in. And for those of you that are not sure what that is, I'm going to just show you one here that I had pre-soldered on some pins. I make them breadboard ready. That's the little 3 volt one. The 5 volt one looks exactly the same, but you have to look really close, and I know it's not going to show up on this. Well, maybe it will. It's hard to tell with this camera. My preview screen is quite small. That just is a linear power regulator, so you put in your voltage. I think it's something like 4 to 9 volts, and it'll give you 5 volts, or sorry, in this case 3.3 volts. Pretty flat and steady. Needs a couple capacitors, but in some things you don't even need the capacitor. I mean, some devices it's plenty good enough, but really you should have a little smoothing capacitor or 2 on that, but that's a whole other video. Here he also sent me my power supply. Excuse my cold there. Oh, I keep bumping the camera. I'm not used to it yet. This is a little switch mode power supply. I think it's good to 2 amps. I'm not sure, but I might also try that as well. So I'll use the 5 volt in, and then use this to run the ESP. But I'll probably use that for testing purposes. I'll probably just use the one switching power supply, bring it down to 5, and then run the ESP off a linear 3.3. And of course, my recently rebuilt ATX power supply to bench power supply has a 5 volt and a 3.3 volts, so I could get real lazy just during testing and use that. All that's pretty easy and possible now. But anyhow, that's pretty much all I wanted to follow up with. Again, was getting the infrared motion detector working properly on this chip with a new library, and I'll put that library down in the description, a link to that. I'm not sure if there's any better ones out there. There could be, possibly, if one of you guys have a really good library working for this chip, that'd be handy. Want to try and find one that's also going to work on the ESP8266, so it'll be nice and easy. The other one was pretty lightweight, again, low memory footprint in the previous library, but it was missing, or didn't seem to be as functional on the input. Now what I might do, from what I've learned on this one, I'm just going to take a quick second to mention here because it's worth mentioning, these chips have a really high pull-up resistor, and you have to enable that for input to work. Like Arduino's, the simplest thing to do is set the pin to input and then set it to high, digital write it to high. That turns on the pull-up resistor, and this one's quite strong, so these things output a positive. The pin goes high when they see motion. Well, normally you wouldn't see anything, so what I had to do is I got, just right now, I have a 4.7K resistor here pulling that back down, just enough to get below the logic level of low, the threshold for a low, so that when this goes high, it's just enough to trigger it to come on again. And it seems to be working really well now. Now, a combination of that library and figuring that out, or this resistor might be it. So I might run another test and just mention it in the next video, whether the original library will work if I remember to pull the pin, or set the pin high after setting it to read. So basically it'd be just like the old Arduino. You set the pin as an input, and then you digitally write the pin high, and then normally you would just be detecting this pin shorting to ground or going through a resistor to ground, but you can pretty much short it straight to ground. It's safe because it's got a pull-up resistor in there. But what I needed to do was read something that was high, so I needed to pull this back down a little bit, enough to show up as a low, but not a complete low, because you don't want to short this out. And it seems to be working pretty good. and hoping I covered all that there. And as always, thanks for watching, and hopefully you'll see the next steps when I get the ESP8266 version working. If you're interested in that, subscribe or comment, and hopefully I'll see you next time.